Hey everyone, welcome back to my channel. Have you ever wondered how astronomers explore the vast universe? What role does light play in this exploration, and how do telescopes work? In this video, I'll explain everything you need to know about light and telescopes. So, let's get started. First things first, let's talk about light. Light is a form of energy known as electromagnetic radiation. What we see as visible light is just a tiny part of a broad spectrum that includes everything from radio waves to gamma rays. Light is made up of packets of energy called photons, and these photons travel in waves. The distance between one wave and the next is what we call wavelength. Understanding light is crucial because it's the first step in our journey to explore the universe. Moving on, let's discuss telescopes. These are not just magnifying glasses for the stars, they serve two primary functions. First, they gather light. The larger the telescope, the more light it can collect, allowing us to see fainter objects in more detail. Second, they resolve detail, meaning they can distinguish small details. Larger telescopes generally have a higher resolving power, making them invaluable tools for astronomers. So, how do telescopes capture light? Well, they use mirrors and lenses, or sometimes a combination of both. Reflecting telescopes use a large mirror to collect light and focus it, while refracting telescopes use lenses to bend light to a single point. There are also catadioptric telescopes that combine both mirrors and lenses, offering the best of both worlds. The refractor telescope excels in offering crisp views of planets and the moon, thanks to its superior optics. The reflector telescope is your gateway to deep space objects like galaxies and nebulae, as it captures more light. The compound or catadioptric telescope is a versatile choice, ideal for observing both planets and deep space phenomena. Finally, how do we actually observe light from these telescopes? This is where eyepieces come into play. An eyepiece is essentially a magnifying glass that magnifies the image formed by the telescope. With the advent of technology, we now have digital cameras that can be attached to telescopes, capturing long-exposure images and revealing details too faint for the naked eye. Now, let's take a moment to appreciate the marvels of engineering that have significantly advanced our understanding of the universe. I'm talking about the world's strongest telescopes, which have been instrumental in capturing breathtaking images and data from far-off celestial bodies. Fermi Gamma Ray Space Telescope, also known as GLAST, this telescope was launched in 2008 and specializes in detecting gamma radiation. It's positioned outside Earth's atmosphere to better study phenomena like supermassive black holes and neutron stars. Spitzer Space Telescope, this infrared telescope was in operation from 2003 until 2020. Unlike most telescopes that orbit Earth, Spitzer orbited the Sun and provided us with views of space that optical telescopes couldn't achieve. Keck Telescope, this one's for the Earth-based telescope fans. Located on Mauna Kea in Hawaii, the Keck Telescope boasts a 32.8-foot diameter mirror. Its high-altitude location minimizes atmospheric distortion, giving us clearer images. Hubble Space Telescope, a name synonymous with space exploration, the Hubble has been in low Earth orbit since 1990. It has given us some of the most iconic images of space, all without the interference of Earth's atmosphere. James Webb Space Telescope, the newest kid on the block, launched at the end of 2021. It orbits 1 million miles above Earth and is expected to revolutionize our understanding of the early universe and exoplanets. And that's it for today. Thank you for watching. Please remember to give this video a thumbs up, subscribe to the channel, and leave a comment. Until next time, keep exploring.